Hello everyone, and welcome back. As mentioned, in this lecture, we're going to work through the solutions to the practice activities that we went over last time. Let's move on over into Jupyter Notebook and get started. Okay, starting with the very first question here, we just had to import NumPy and Pandas with their aliases. This was a very easy one, so we just had to say import NumPy as NP and then import Pandas as PD. Then I asked you to create a series with 5 random numbers going from 1 to 100 using NumPy. To do this, we'll just go ahead and create a series with the pd.series function, and then inside of our parentheses, we'll pass in np.random.randint to create an array of random numbers, and then it will provide this with a start value of 1 and then a stop value of 101. As remember, our stop value is not included, so we have to go one above where we actually want to stop. And finally, we'll just have a size of 5. Okay, perfect. Then I asked you to go through and perform a couple of different mathematical operations to each element or number in our series. So just add 10, subtract 5, multiply by 3, and finally divide by 2, which we can do for each of these just like this. And the reason that this works is because of what is referred to as element-wise operations, which we covered earlier on in our sections on NumPy and Pandas. Moving on to activity 2, we had some questions on data frames. I provided you with a dictionary, and then I asked you to turn this into a data frame, which we could do with the pd.dataframe function. So I'll just say pd.dataframe, and then inside of here, I'll pass in the name of our dictionary. And then I'll assign the result of this to a variable, which I'll call df. We then needed to index this data frame, which hopefully you remembered we can do with square bracket notation. I'll just go ahead and say df, and then here we wanted the name column, so I'll just put name inside of our square brackets to index our data frame at the name column. To select both the name and age column, we could pass in a list of lists with the names of our 2 columns inside. To change our data frame to have an index of A, B, and C, we could have used the setIndex method. So df.setIndex, and then we wanted an index of A, B, and C. And also, we'll need to set the inPlace argument to be true, so that this change is actually made on our original data frame as well. And then if we check the contents of our data frame now, we can see that our row index has been set to A, B, and C, as opposed to 0, 1, and 2, as it was before. Indexing our rows can be done with either iloc or loc. And starting with iloc, this works for integer-based indexing, so we would need to pass in the row index number. Select the first row, this would be a 0. And then for loc, this uses an actual label, and we just set our index labels to be A, B, and C. So to select the first row, we could just say df.loc, and then the label of A. And then to slice this data frame with iloc, we can just use our same square bracket notation, but with a colon to specify our slice. For row 2 and 3, we'll need to slice from index position 1 to index position 3, as our first row will be at index 0, and then the stop value is not included, so we have to go 1 index past where we actually want to retrieve to. And then for this single question here on creating columns, the question was just on creating a new column called birth year, which is equal to the current year minus that person's age. To create a new column, we'll use our same square bracket notation as we do when we index our data frames. But if we enter in a column that doesn't exist and then say that this is equal to, we can create a new column. So just birth year is equal to 2024 minus the age column from our data frame. After this, we moved on to looking at some different data frame methods. Using our same data frame as before, I asked you what method you would use to display the first 5 rows of a data frame. The answer to this is the head method. So df.head would return the first 5 rows in our data frame. On the flip side of this, tail can be used to return the last 5 rows of a data frame. However, in this case, as our data frame only has 3 rows, then head and tail will return the same rows. But of course, if our data frame is larger, then these would return a different result. Additionally, if we pass a number into our parentheses, we can specify how many rows we want to return. So I could say df.head, and then if I pass 2 in here, that would just return the first 2 rows of our data frame. To create summary descriptive statistics about our data frame, we can use the describe method, which will return descriptive statistics for every numeric column in our data frame. Our next 2 questions here were on sorting. So initially, I asked you to sort this data frame by the age column and in ascending order. To do this, we could just have said df and then call our sort values method. And then for our argument, we just have to specify what column we want to sort by. I'll just provide the age column, and then if we run this, we'll see that our data frame is returned, but sorted by the age column in ascending order. To sort this in descending order, we can pass in the ascending argument and set it to be equal to false. And then to finish off our activity on data frames, we had a question on conditional selection. All we had to do was return a Boolean series of true and false values for where our city is equal to New York. We'll select our city column from our data frame and just say where this is equal to New York. To index our data frame with this Boolean series, we'll just pass this whole line of code here in as an index to our data frame, and that will then return the actual row with the associated data for where our city was equal to New York. And this here is a very helpful and essential skill to have, so make sure that you remember and understand this one. Okay, and then we were on to activity 3, which was on pivoting. For this question, I provided you with a very similar dictionary to what we used in the last section, which just contains some information on different student scores. Except for this time, it's got detail on the city that they're from, as well as their attendance, which is categorized into either good or poor. I'll just quickly cast this to a data frame. And then for our questions, we had to create 2 pivot tables. The first one showing the mean test score for each subject by the attendance level, and then the second one showing the mean test score for each subject by the city, but also split by the attendance level. Starting with our first one here, we needed to look at this information by the attendance level, so I'll pass that in as our index, and this will create 2 rows for our good and poor attendance categories. Our values will be a list of our 3 different subjects, so English score, math score, and science score, and then finally we'll specify which aggregate function we want to use, and I'll set this as mean. And then running this will return a pivoted data frame showing the average scores for each subject, but broken down by the attendance in our rows. Also, you may remember from the last section, I mentioned that the ag_func argument actually uses mean by default, so we don't actually need to specify that here. And then for our second pivot table, we needed this to be the average test scores by each city, but also split by attendance. We'll start off by calling our pivot table method again, but this time we'll set the city column to be our index, and then our values will be the same list as before, so I'll just copy that over from our pivot table above. But then this time we'll also have to specify the column argument to break our pivot table down even further by the attendance. And we'll just have this be equal to the attendance column. And then we don't need to set the aggregate function argument, as this is the mean by default. And perfect. So we've now got rows for each of our cities, and then our values are the average test score for each subject, but then with another column showing us the difference between good and poor attendance. Due to the way in which I generated these random numbers, they're all very similar to each other, but mainly it's just a good example to practice the pivot table method on. And just to add here, we could also have done this the other way around, so putting our attendance column in for our index argument, and then cities for our columns, but this is really up to your personal preference. I prefer to have more rows than columns. And then here, we just had a very quick activity on merging. So provided with these two data frames called df1 and df2, we had to merge them on the ID column with an inner merge. We'll just call the pd.merge function, and then we'll pass in our two data frames that we want to merge, which were df1 and df2, and then we'll say that this is on the ID column, and then finally we can specify an inner join with the how argument. But as mentioned, this function does actually use an inner merge by default, so we don't actually need to specify this. Our final activity for this lecture was on dealing with missing data. Using this data frame here, I asked you to use the techniques that we learned about in the last section to deal with this missing data by either dropping the rows or filling in the missing data. Starting with dropping our missing data, we could just type in the name of our data frame and then call the drop NA method like this. Like we looked at before, this method will drop any row that contained missing data. But if you want to modify the method to retain rows containing only a single missing data point, we could use the thresh argument. As this data frame has 4 columns, we would need 3 of these columns to have data. So if we just say that thresh is equal to 3, then as long as a row has at least 3 populated columns, then it will be kept. And then to fill our missing data points, we could use the fill NA method instead. Our first one here was pretty simple. We just needed to call our method, and then for our argument, we'll provide the number of 1000, which will then fill all of the missing data points with the value of 1000, as we can see here. If we wanted to fill our population column with the mean of that column, instead of specifying a fixed value of 1000 for our fill, we could actually pass in that column by indexing the data frame and then passing in the mean method on this column. And then looking at our results here, the missing row in that column, which was Los Angeles, has now been filled in with the mean of the population column. To fill the average temperature column with the median, we could follow the same steps as before, but of course replacing our population column with our average temperature column, and then instead of mean, we'll call median. Okay, and great job there. That's it for our practice activities on Pandas. I hope you managed okay with most of these, and that Pandas is starting to make sense. We'll be using it throughout the rest of the course, especially when we come to our data analysis example and portfolio project sections, so we'll have plenty more time to practice these skills, as well as learn a few more bits along the way. If there's any questions there that you weren't able to get, then please go back and recap anything that you were particularly stuck on, or feel free to ask down in the Q&A section below. and I'll be happy to get back to you and help you out. Let's leave this section here, and then in the next one, we'll begin looking at how to visualize our data inside of Python, starting with the matplotlib library.